There are several different types of wall forms. There are job-built forms, and then there are patented wall form systems.
Our objectives for today are:
1. We need to be able to identify basic types of concrete wall forms. 2. We need to be able to define patented wall form systems. Lastly, we need to be able to describe the setup and assembly of wall forms. If you need an 8-foot-high, 8-inch thick retaining wall, and there's only 50 feet of it on the project, you should go with the wood system. Just because of how fast you can get the materials, you got instances where you would build wooden forms with frame and lumber or dimensional lumber and 3x4 CDX plywood or ply form. You would nail those together. On a job site with a small scope, wood forms are the way to go, especially with Haskell. We've got a lot of great foreman carpenters in the company, and they really excel in that type of form work. If you have a small wall to put up, you typically would build it, get the lumber, build the forms on site. So they're good single use. Cost is not that high because you don't have to rent them. It's a one-time purchase, single use. But if you take care of them and build them as modular panels, you can use them multiple times. If they're treated well, if you clean them, use form release oil on them, and they don't stick to the concrete after it's poured, they can be used more than once. Remember to use form oil if you're going to use a job-built form system for more than one use. You want to make sure all of your fasteners are tight. Once you break that system apart and you clean it and go to store it, that would be the time then to go through your checklist to see if you got cracked lumber, or if you've got plywood that's just delaminating. There's also gang forms or a slip form type system. These are pre-manufactured forms. They could be all steel. Some are aluminum framed and they have an engineered wood substrate, and that has got a coating on it that helps prevent the concrete from sticking to it. I've used those in the past for shear walls for elevator shafts. Now the slip form system, that's a whole different discussion, but it's in that same kind of family of forms, the pre-manufactured type. The gang forms and the slip form systems are a different application, but it's still a poured wall. With the gang form, slip form systems, there are a lot of different components you're assembling. In a gang application, that's 3, 4, 5, 6 panels together at one time. You usually assemble gang forms on the ground or on work tables. Then you move the form by crane. You want to lay out the formwork according to shop drawings? Assemble the form sections according to the manufacturer's instructions. Place and install the lifting eyes. Make sure the braces are properly installed. Invert the form section and place the form liners, reveals, and any other materials. Lubricate the lifting hardware and releases before lifting the form. There's anchoring that needs to happen with those panels, and then also with that slip form type system, you've got elevated work platforms. They've got brackets and occupational safety and health administration approved handrail that gets mounted to these slip forms as well. With the slip form system, there's a lot of fastening attachments to keep those gang forms together. Those should be checked periodically, or if there's some unwanted movement or you see something when you're hoisting to the next level, address that immediately. You would have a select few general foremen or superintendents who would oversee that work. You would send those guys or gals to get the technical training from the manufacturer, and they would come back and conduct a site training with the crew. They would assign people to do certain things and then, of course, back check and make sure all the safety items are in place and the bolts are tight and all that. And then you have the steel forms, Simons. They're a metal frame form with a ply form substrate in pre-sized panels. It's almost like a modular system. You don't use whalers in a Simons form system like you typically would with a wood frame form system. The frame has structural ribs in it that keeps the form itself from deforming under load. If you have a 30,000 square foot warehouse that has 10-foot high foundation walls, you should go with the Simons system. Just because of the speed and ease with which you can get that formed up, poured, stripped, cleaned up, and be able to continue with construction of the building. Simons forms are good because it's an engineered system that has all the components with it. They're easy to understand and learn how to put together. You wouldn't need to send 20 to 30 guys and gals to technical training at the manufacturer. It would be a concrete general foreman or superintendent that would then come back and do a hands-on training session at the site or in our warehouse with his crew. You don't have to go to an outside vendor or third-party vendor to get anything. You can stack the panels upwards of 16 to 20 feet. But anything higher than 20 feet, you would use gang form or slip form system. You wouldn't build a 30-foot high wall with a Simon form system. They've got wedges and clips that hold panels together. It's a double wedge system, so you'll have a wedge that goes through a pre-formed slot horizontally, and then you'll have another one that drops down vertically. You tap it a couple of times with a hammer, and it's just a simple wedge system that locks those panels together in a line. There's no bolts and parts and pieces. Then you have wall ties, or some people refer to them as snap ties, which lock the formwork together on both sides of the wall. Once the wall is poured, you break your formwork away. You take the wedges out, and then what you're left with is a little piece of metal that sticks out on both sides of the wall. It's relieved on both sides of it, so there's not a whole lot of metal there. And then you just take your pliers or hammer and you break that tab off. If it's an exposed wall, you rub and patch those snap tie areas just to make them blend, so you don't have craters where those snap ties were. You smooth that out with a cementitious product and you are done. Simons are multiple use if they're taken care of, but it all depends on how they're treated and how they're cleaned and stored and maintained after use. If the frames are bent or broken, or if the plyform material is damaged, whatever damage is on that plyform side that faces the concrete is going to end up in the face of your wall. Always make sure you have the correct wedges and pins to lock these panels together, and if those slots that are pre-manufactured are oblong because somebody came with a torch and made it bigger than it should have been, that's going to modify that. That's not what the manufacturer built, and if it has been modified in the field, it shouldn't be used. It should be discarded or cut up so nobody can use it down the road. Do not just set aside something like that because somebody will think they can use it and something bad could happen because of that. Let's take the wood forms, for example, and let's assume you are going to put on a spread footer. You would get your layout done. If you are building a 30,000 square foot building, you are going to square up your layout before you set any form work. You want to make sure that your walls are square to each other. You'll have vertical reinforcing rods coming out of the footing. You would get your layout from your panels. You would start your reinforcing if it's not already done. And at that point, you would install one side of the vertical wall forms. You need to anchor those to the footing or other type of material that you're anchoring to. You would get that one side of that wall form system braced, plumbed up. Make sure it's straight and plumb and level to the footing. Then you would start installing your wall ties through the side of the formwork that you just installed and braced and plumbed up. That helps support the reinforcing that's in the middle of the wall as well. Once the wall ties are in, you install your wailers behind that, and then you would install your wedges which lock in the end of the wall tie. Now that you've got one side locked in, you've got your snap ties in where they need to be per the drawings, and you've got that wall braced. You use that as your base to set the other wall form on the opposite side. You'd get the wall stood in place. You would get it leveled off with the wall on the opposite side. Bring your snap ties through that opposite form. Put on your wailers and your wedges. Get those locked in. And what that does is locks that whole wall system together. Once you get those locked together, you should double check it before you brace off the second side. Check it with the level. Check it against the benchmark if that's what you're using to get your elevation. If you're using a 4-foot beam level and it tells you it's plumb, you could double check it with the transit. And then you would go ahead and secure your bracing on the opposite side of the wall. Never drop food wrappers, water bottles, or other items into the formwork. Always put these items in a pouch or in the garbage. If you drop water bottles or other items down in the wall, it creates voids in the pour which structurally weaken the wall. At some point, that plastic bottle or whatever food you throw in there is going to break down, and that void could affect the structure of that wall. If you've got a big reinforced wall, there'll be some structural recommendations from the engineer. They could recommend a particular type of form system. If not, they might give you the option to use a job-built forming system, in which case they would tell you the spacing and size of the wall forms or the wall ties and go from there. And then the Simons forms have their own bracing brackets, and they have turnbuckle or a screw system. And you can adjust the in and out of the panels with the turnbuckles and then lock those in soon as you're plumb. Make sure that the reinforcing steel is in and installed properly per the structural drawings and the rebar shop drawings. Have a third-party testing agency or engineering company come out and do an inspection on it. They'll note in their inspection report that, yes, the reinforcing in this wall section was installed per the engineering drawings and the rebar shop drawing. You would then do a walkthrough with the crew to look for missing bracket retainers, missing wailers, missing braces that need to be put in because, again, where you have the missing reinforcing or missing component is where you're going to have a failure. It's better to overbrace than not brace enough. You will not have a failure from overbracing, but if you put less than what the engineer shows on his drawings, you are going to have a failure and lose the wall pour. And in the worst case scenario, somebody ends up buried or the wall collapses on somebody and kills them. Sometimes you need to stage the formwork in preparation for construction. So, you get the formwork from the storage yard or leasing company. You check the components and hardware to ensure you have everything you need. Then you gather all the tools you need, wrenches, pry bars, what have you. You lay out the wall on the foundation and prepare the sill to receive the form. As you're pulling the form system off the wall, you need a lay-down area for your formwork. You don't want to store any type of formwork directly in the dirt or in the soil. You want to elevate it up off the ground. Stack the panels on a level surface or level area of the site. Before you stack it, take a stiff brush and brush off any dried up concrete on the form surface or the surfaces where the panels mate tight together with the wedges. You don't want any voids in those areas because if the voids are excessive, you could have concrete coming out of there. Any material on the formwork that isn't part of the manufacturing process should be removed. Let's say you've got job-built form systems and you maintain them and you're using them multiple times. Before you store those, you should coat those surfaces with a form release oil. That will prevent things from sticking to that and will keep them from becoming too dried out. It's important to clean steel forms after each use. Get any concrete or form material off them, coat them lightly with oil, and that will prevent any rust and corrosion bleeding into the concrete when it's wet. Blocking works very well when you're stacking panels. You want to stack them with their platform surfaces face to face. That prevents materials from the site falling on it and damaging that form surface. It also prevents people sitting on them or spilling food on them. If you can, you want to store them out of the weather. It doesn't have to be inside a building, but you don't want them to get covered in rain and moisture all the time because the Simon forms are steel, so they will rust. Even though they're coated from the factory, they get scratched. The steel surface gets exposed. You'll have rust and then you will have bleed through with the pour. You want to have separate bins or buckets for the bolts, nuts, pins, wedges, keys, and ties as those form systems come apart. You don't want a mixed bucket of all different parts and pieces. You'll be searching through the thing and that creates a lot of unproductive time. It affects the overall cost of the job because now you're wasting money here. You could spend a little time when you're taking the form system apart to put all these parts and pieces in separate bins. You know where they're at, and it improves the performance of the system and then increases productivity for the guys installing the systems on the next pour. When it comes to safety, there's a long list of things that can really go sideways on you if they are not addressed properly. 1. How many lineal feet of wall are you trying to pour at one time? 2. Do you have the proper supports? 3. Is the wall braced properly? 4. Do you have your fault eyes for the engineered drawings? And again, this all goes back to the type of walls or the form system you would use. You always want to check your handrails, your brackets, and your elevated work platforms. You have to realize that there are things that can happen when you're away from the job site. Before starting work, check your equipment. Check your platforms before you get on there and load them up with people. You might have gone home early because you have a 3 a.m. pour the next day, and while you were away, somebody on the job site hit your work platform with a piece of equipment and was afraid to tell somebody about it. And you come in the following morning at 3 in the morning when it's dark out, getting ready for this pour. You climb up on your platform and you could possibly fall or get injured or even die because somebody was afraid to say, "Hey man, after you guys left, I hit your platform with my forklift. I don't know if I did any damage." Another thing to think about is the height of the wall. You need to be tied off on anything above 6 feet. Are you tying off to the actual wall system itself? Those engineered tie points? Then, if you're pouring a wall that is taller, you're going to have more weight and more pressure on that formwork, so you need to make sure that that system is secure. If you have an 8-foot high, 8-inch thick wall, the pressure pushing out on that formwork is going to be less than a wall that's 10 feet or 16 feet high of the same thickness. That downward pressure from all that concrete just tends to want to blow the forms out towards the bottom. That's usually where they fail if it's not braced properly or if the bottom of formwork is not secured to the footing properly. If you're using a Simon system, make sure you're bracing and you're locking the panel together per the manufacturer's instructions. Another big item is your subgrade. What are you putting that wall on? Are you putting it on lime rock? Are you putting it on a compacted base? Are you putting it on sand? Are you putting it on a concrete footing? If it's an unstable or uncompacted subgrade material, you could have a failure, not only with the pour, but with the actual formwork. Another consideration is the grading. Are you on a sloping grade? Not everything we build is on a flat surface or a flat ground. If you're on a sloping grade, how do you get concrete there? Are you trying to get it there with a concrete bucket? Are you making it harder for your manpower to place that concrete and get it where it needs to go? Just in general, safety comes down to spatial awareness. Remembering what you're doing, where you're at, not stepping backwards without looking where you're going. You could fall off the formwork. You could fall into a hole. You could trip over some bracing. You can get hurt if you're not paying attention. You have to think about what your workforce has been trained on, what they're comfortable with, and what they're efficient at working with. There's nothing wrong with trying a new wall form system or going and trying something that you think might be a better application or increase production or reduce man hours. But you're not looking to train 10 guys or gals on a new system. If they're not familiar with the system, getting trained or certified or what have you, just the cost of the training and getting familiar with it could be a problem. The least labor-intensive is a slip form, gang form system, and the most labor-intensive are the wooden forms because you're building the panels on site. You should use a system that's appropriate for the application. I'm not going to build wood forms on site to build foundation walls for a 30,000 square foot building with 10-foot high walls. It's a waste of labor hours, and the cost of the lumber to do that would exceed the cost of renting or even buying a Simon system for that application. Simon forms require more hands-on labor than equipment, but again, they're modular. They've got their own components. It's an engineered system where they have everything you need to assemble it. They go quickly. You don't need a forklift or a crane to lift the panels. They can all be carried by a single person on the site. So, if you got a stack of forms, one guy could set a run of Simon forms pretty quickly. The job-built wood forms are kind of labor-intensive. You have to make everything that you need. You have to frame and sheathe the form panels. But, on the other hand, everything is pretty much reusable. The whalers, the panels, etc. A lot of guys figure they're single-use, so they're not worried about cleaning them. A lot of times they won't even use form release oil, which is a big mistake because the plywood delaminates and then it sticks to the wall. And then you've got a lot of rubbing and patching afterwards. With the gang form slip form system, you've got some one-time upfront labor costs to assemble the form system. But on the other hand, you don't have to really modify it once you have it assembled on the shear wall or shaft wall that you're building until the shear wall or shaft wall is poured out complete, at which point you would disassemble the sections in the air by crane and fly those to the ground and store them. But with the gang form slip form system, you typically need a good-sized crane on site to do that type of work. If you're in a mid-rise building and you've got a tower crane or other types of cranes on site anyway, it's not a bad system to go with. You got some costs with a crane, but once the system is assembled, it's easy to use, and you don't have to modify them until you take them off the building. The gang form slip form system really is not cost-effective unless you have the right application for it. One, because if you don't own them, you have to lease them. The leasing costs can be pricey. The system is shipped in multiple trucks. And then if it's damaged, you've got costs there to replace the parts and pieces. There are several things to look out for during wall pours. Consolidation is a big problem with a lot of wall pours. If you are pouring a 10-foot high wall, never take the end of the pump hose right up to the top of the formwork and just start dropping concrete. You don't want that concrete to fall more than 6 feet before it gets to its final location. If you let it fall 10 feet, it's going to hit with so much force that all the aggregate is going to be forced down to the bottom. At that point, it's not a well-blended mix anymore. All the aggregate drops and you lose a lot of strength. Your mix is not the way it was designed originally. You want a mix that has the right slump? You don't want a low slump concrete. For example, trying to push a 4 slump through a concrete pump? The pump operator probably won't even do that for you. You do not want a 57 stone aggregate in the mix because it's too big. If the rebar is packed in tight like it would be for a shear wall, you can have a lot of trouble with a mix with the pure 57 stone aggregate blend. Is the reinforcing steel pattern 12 by 12 spacing? Is it 16 by 16? Or is it 4 by 4? That all affects the mix, and it affects the placing of the concrete in the wall, because it's harder for that mix to get around all that rebar, especially with a larger aggregate blend in that mix. If you use too big of an aggregate with a tight reinforcing mat in the wall, it's not going to consolidate properly around the rebar. It's going to make it harder to vibrate, harder to get that concrete where it needs to go, and when you pull the forms off, you could have cold joints. You could have a lot of honeycombing, which requires rubbing and patching, and depending on the engineer, the honeycombing might be too much for them. And worst case scenario, you're taking that whole wall section down and redoing it. Nobody wants that. If you're using a high early mix, concrete is going to set up on you a lot faster. And then whatever admixtures that are called for by the engineer also affect the concrete and its performance and how quickly it tends to set up. The location of and access to the pour on site affects the lifespan of the concrete once it leaves the batch plant. That's why you'll see a lot of big continuous pours start at midnight or 1 o'clock in the morning. You might even be adding ice to the mix to keep it cool. If you're pouring big wall and you pour it at 2 o'clock in the afternoon in the middle of summer in Florida when it's 95 degrees out, the mix is either going to overheat in the truck or it's going to want to set up on you faster because of the heat, air temperature, and the weather are a big factor in it. Finally, remember to use foam release oil. It makes the wall look a lot nicer when it's complete. You won't have a whole lot of rubbing and patching to do because your forms are not sticking to the wall. Some curved wall panels are made of flexible steel or aluminum panels shaped by curved ribs. These panels are placed into special templates, and their tension bolts are adjusted to form the panel to the curvature of the template. Others use curved wailers combined with metal or wood strongbacks. Panels with flexible joints may also be used. Curved forms can also be made from wood. In a curved wood frame, the top and bottom plates of the form panel, as well as the panel itself, are made of plywood. If you need to bend plywood form panels into small radius curves, you cut curves in the plywood with a circular saw. It's better to use 2 thinner panels than curve a thick sheet. And remember, a bend made with the face grain can achieve a tighter radius than one made against the face grain. You install bucks between the inner and outer wall forms. A typical buck consists of a plywood or lumber frame reinforced by spreaders and braces. Check the rough opening size from the plans or manufacturer's specifications, and check for plumb and level throughout concrete placement, because once the concrete hardens, you won't be able to make corrections. Remember to make a hole in the lower spreader of a window buck to vibrate the concrete below the buck. You install small wood box frames, rigid foam plastic blocks, or frames made of sheet metal or fiber to make small openings for vibrators, ducts, vents, pipes, etc. And remember, every operation needs a hazard analysis during a team huddle before we start. Thanks for watching, and remember, you are the key to our company's success and safety. See you out there on site.